Hi Nat 4, Nat 5, welcome to Homologous Series Lesson 6. So as usual, there's a wee starter here, so I'll read them out and then you can pause the video and then start answering. So question 1, what is the name of the very first member of the alkene homologous series? Okay, so how will we think? We're thinking about alkenes, what's the very first one? Question 2, I want you to name that alkene, and then question 3, I want you to draw this molecule here fully. Okay, so pause the video, do the questions, and then I'll go through the answers. Right, very first one, what is the first member of the alkene homologous series? It is ethene. Okay, now remember, we can't get methane because in alkenes we need at least one carbon to carbon double bond, and methane is just one carbon, so we can't get methane if we need to have at least 2 carbons in. Okay. Next question, name this alkene here, just see above. So if we look at this, what is our longest chain? So our longest chain is 1, 2, 3, 4, 1, 2, 3, 4. We don't get long on 4, so it is bute, because bute is a prefix for 4 carbons. And what side do we start from? Do we start from the left or do we start from the right? We start from the right. Why? Because it's closest to the carbon to carbon double bond. So that's 1, 2, 3, 4, and then we circle our branch. Okay. Now we'll name the alkene part first. So the carbon to carbon double bonds between carbons 1 and 2, and you should know by now we pick the lowest number. Okay, so this becomes bute 1-ene. And our branch contains only 1 carbon, so our branch, we call that methyl. Okay, you should be getting the hang of naming branches and stuff like that. And where is our branch attached to? It's attached to carbon number 3, so this becomes 3-methyl bute 1-ene. Sorry, my voice is quite sore today. Question 3, I want you to draw this fully, so draw what you see. So we see a carbon with 3 hydrogens, just like that. Then we see a carbon with just 1 hydrogen. And then we see a carbon with 2 hydrogens. Okay? So, we've got that, but you can see that this isn't fully saturated. Every carbon doesn't have 4 bonds. 1, 2, 3. This carbon's got 1, 2, 3. Okay, so we can't add any more hydrogens because that's what a molecule is. So what did we need to do? We need to add a carbon to carbon double bond. Okay, so here we've got propene. Okay, and we don't call it prop-1-ene because it's the same molecule if we flipped it. Okay, so this is just propene. So really well done if you got that one. That's impressive. Right. So what we're going to do now, today, is we're going to look at saturation and unsaturation. Now, let me just get my bullet points up. Right, so first things first, we're going to talk about what saturation, what unsaturation means. Okay, so if a molecule is saturated, okay, so we'll go for a saturated hydrocarbon. Now remember, a hydrocarbon contains only carbon and hydrogen. Yeah, we did that back in 3rd year. So a saturated hydrocarbon contains only carbon to carbon single bonds. Okay, so the 2 homologous series that is your alkanes and your cycloalkanes. Yeah, every single one of them contains only carbon to carbon single bonds. Now, if you're unsaturated, okay, so if you've got an unsaturated hydrocarbon, they contain at least one carbon to carbon double bond. Okay, and we learned about them the last lesson. That is your alkenes. Okay, so you need to know the difference between a saturated hydrocarbon and an unsaturated hydrocarbon. Okay. So what we're going to do now, I'm going to explain how we test for saturation and unsaturation. Okay. Right. I don't know about Mrs. Fleming's and Mr. White's class, but my two classes, certainly when we were in third year, we already covered this just very briefly. So I'll quickly go over it and then we're going to go into just a wee bit more detail. Okay, so to test for saturation, unsaturation, what we do is we use bromine water. Okay, now bromine water is just Br2, and it's Br2 because bromine is diatomic. So it's bromine bonded to another bromine, yeah, Br2. Right, now, the colour of bromine water is orange. Okay, so bromine water is orange. You can also say brown as well. It's like a brown orange. It's quite hard to describe. Don't worry, I will be putting a video up of the experiment. So bromine water is actually browny orange colour. Now, what happens? Alkanes cycloalkanes. So basically, saturated molecules, okay? So saturated molecules have no effect on bromine water, okay? So if we add bromine water to an alkane, it stays that sort of orange-brown colour. Now, what happens if we add it to alkenes? Alkenes decolorise. Decolorises bromine water. Okay, so it goes from that brown orange colour, if I can spell, brown orange colour to a colourless. Okay, and that there, you need to know that. It's so important that we know the test for alkenes. So if we add bromine water to an unknown solution and it decolorises, we know that it contains a carbon to carbon double bond. That makes it unsaturated. That makes it an alkene. Okay, so make sure you know the effect of alkenes on bromine water on alkenes. Sorry. Right. So at this point here, I'll have uploaded to the teams. I'll have uploaded a YouTube clip on this sort of experiment here. So you might want to pause this video and then watch that experiment, okay, just so you can get a visual idea of what it looks like. Right, so what we're going to do now is we're going to, in fact, I might actually take another page. In fact, let's do an example, okay. Very quickly, if we just draw this molecule here, so this is but-1-ene, yeah, longest chain's 4, 1, 2, 3, 4, carbon to carbon double bonds between 1 and 2, so we use the lowest number, so that's but-1-ene. And if we go for this molecule here, that is cyclobutane, because it's in a ring structure and it's got 4 carbons, so cyclobutane. Now, out of these two, what one would have an effect on bromine water? If we add it to cyclobutane, cyclobutane is saturated, okay, because it contains only carbon to carbon single bonds. So if we add that to bromine water, okay, so add bromine water, there's no effect. Okay, nothing happens, the bromine water remains orange. Now, but-1-ene is unsaturated, okay, and it's unsaturated because it contains at least 1 carbon to carbon double bond. Now, if we add bromine water to that, what happens is that the bromine, I'm just going to shorthand this, the bromine water decolorizes, okay, so it goes from that brown to orange to a colourless, yeah, to colourless. So yeah, that's just read 2 examples there, unsaturated, saturated. Right, what we're going to move on to now is addition reactions. Addition reactions. So if a molecule contains a carbon to carbon double bond, other molecules, other small molecules can be added over this. Okay, so that's what we mean by an addition reaction. If we contain a carbon to carbon double bond, we can add a molecule over that carbon to carbon double bond and create a different molecule. Okay, so what I mean by that, let's just go for, we'll just go for 4 carbons, keep it nice and easy. Okay, so this molecule here is but-1-ene, but-2-ene, and what we can do is we can add a small molecule. Now we've been working with bromine water, so we're just going to add that over it, so that's going to be Br2, and if I was to draw that out fully, that would be Br bonded to Br. Okay, now what happens, and this is a cool part, okay, we've got that carbon to carbon double bond there, is that the carbon to carbon breaks. The double bond breaks. Okay, so it breaks up. Just one of them. Okay, and then this bromine here, this one, gets added to that carbon, and this one gets added to that carbon. So what we're left with is this molecule here. Now we don't need to know how to name this, we just need to know how to draw it. Okay, I think this is 2,3-dibromobutane if you're interested in the name, but you don't need to know how to name it. So all that's happened is that carbon to carbon double bond breaks into a single, and then obviously the bromine kind of breaks up as well, and then one goes to that carbon and then the other one goes to the other carbon. What's important here is added over the carbon to carbon double bond, nowhere else, and that is what confuses a lot of people. So we're going to make a big star. Okay, so molecules are added over the carbon to carbon double bond. Okay, I can't stress that enough, so important. Okay, now we're just going to have another wee example of that. So if we were to call that number 1, let's call this number 2. Okay, let's go for, again we'll keep it nice and easy, let's just go for propene. Okay, just like that. So that is propene. Now, it doesn't just have to be bromine that we add over, we can add over other small molecules. Yeah, we can add over chlorine if we wanted to. Now remember, chlorine is also diatomic. Yeah, 7 diatomics is the H north down. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Okay, now we can draw that chlorine fully out like that. Okay, now what happens is we highlight the carbon to carbon double bond, because that is the part of the reaction that undergoes the addition. Okay, so we can break that bond up. Yeah, the chlorine also breaks, and one chlorine gets added to the first carbon, and then the other chlorine gets added to the second carbon. Okay, so what we're left with is this molecule here. So we've got one chlorine there and another chlorine on the second, and then the rest is just like that. Okay, so a wee summary. For addition reactions, we start with an unsaturated molecule. Okay, and then it undergoes addition and we get a saturated molecule. Okay, what's the difference between an unsaturated molecule and a saturated molecule? Unsaturated contains at least one carbon to carbon double bond. Yeah, a saturated molecule contains only carbon to carbon single bonds. Okay, so just be very careful with that. Now, what we're going to move on to now is types of addition reactions. That's like a wee subheading here. Okay, so if we add bromine, okay, so if we're adding Br2, BrBr, the type of, it is called an addition reaction, but the type of addition reaction is called bromination. Okay, kind of a a combination of addition and bromine, so bromination. Okay, if we add chlorine, okay, we call this chlorination. And again, it's your combination of your addition and your chlorine, okay, chlorination. If we add hydrogen, okay, I'm just going to, hydrogen's H2, yeah, chlorine is Cl2, and bromine is Br2. Just make sure you know that, okay? So if we add hydrogen, we call this hydrogenation, okay? And these three are so important, okay? So we've got bromination, we've got chlorination, and probably the most important one actually, hydrogenation, okay? Now there is a third one, a fourth one, however, we're going to come back to that later, okay? So if we add water, and you should know by now, water is H2O, okay? If we add water, we call that hydration. Okay, and that makes sense because if you drink water, you're drinking water to stay hydrated. Okay, so if we're adding water, we call it hydration. So it's a combination between being hydrated and addition. Okay, we will come back to that later when we do the alcohols topic. Okay, so see alcohols later. So next one, we're going to do adding asymmetrical molecules. Okay, what we mean by asymmetrical is that molecules that aren't symmetrical. Okay, so for example, H to H, that is symmetrical. Okay, if you put like a wee dotted line, it's the same on either side. However, if we add this molecule, that is asymmetrical, like so. Yeah, so what we're going to do, we're going to start looking at asymmetrical molecules. So this wee note here, if you add an asymmetrical molecule to a symmetrical alkene, you always get just one molecule, okay? And you'll see what I mean by that when I give you a wee example. So let's go for butene. Now, the reason this butene is symmetrical is that if we were to sort of put our pencil down there, it's the same on either side. Okay, so this is asymmetrical, so we call that butene. Okay, now if we're adding hydrogen chloride, like that, remember, just like what we do in our previous addition reactions, we highlight the carbon-to-carbon double bond, like so, yeah? And the carbon-to-carbon double bond breaks, just one of them, yeah? One of the bonds break, and then the hydrogen gets added there, and then the chlorine gets added there. So what we're left with is this molecule here. So hydrogen there, chlorine there, and hydrogen there. Okay, now technically what could have happened is that chlorine adds to that one, and then the hydrogen adds to that one, and we would get that molecule. Sorry, my throat's really sore. And we get this molecule here. But what you'll notice, well, hopefully should notice, is that these two molecules are exactly the same. Okay, in order to go from this one to this one, we take this one and we flip it to get that one. Okay, so these two are the same molecule. Okay, so we are only getting one product. Okay, so we're going through an addition reaction and we're getting one product. And the reason we're getting one product is because this here, the alkene, is symmetrical. Okay? Now, what happens if the alkene's not symmetrical, if it's asymmetrical? So if alkene is asymmetrical, two products can be obtained. Okay, now two products. Let's go for, yep, we'll keep it again. We'll keep it easy. So we'll do propene. We'll start with propene. Just like that. Okay, now propene is not asymmetrical. If we were to put a line down the middle, you can quite clearly see there's 3 hydrogens on the right side, there's 2 hydrogens on the left, there's also a carbon-to-carbon double bond, there's a carbon-to-carbon single bond, so that isn't symmetrical. Now, if we add, we'll just go for hydrogen chloride again. I have to use a different pen. So what happens is that the carbon-to-carbon double bond breaks, and then the hydrogen can add over the first carbon, and then the chlorine adds onto the second carbon. So what we're left with is this molecule here. Okay. Now, what can also happen is that instead of the hydrogen adding to that carbon, the hydrogen could add to the middle carbon, okay? And then the chlorine adds to the carbon on the left. And then what we're left with is a completely different molecule, okay? So here, this is molecule 1, that's molecule 2, whereas before that was molecule 1, that was also molecule 1. So we've now got 2 different products. So 2 different molecules are made. Okay, and why is it made? It's because the alkene is asymmetrical, and you need to know that. Yeah, very important, very important. Right, what we're going to do now, we're going to do some questions, and then we're going to leave it there. Okay? So questions to try. Why are alkenes unsaturated? Okay, what do they contain that makes them unsaturated? Okay, question 2. How do we test for alkenes? Okay, what is the result of the test. Okay, so there's something that we add to alkenes that tells us that it's an alkene. Okay, we add a very specific type of water, you could say. Okay, so I'll leave that there. Question 3. Copy and complete. Okay, so I'm going to give you a molecule. And if we add chlorine over that, what do we get? Yeah, you draw what we get. And the last one, draw the two products that are formed when hex 1ene reacts with HF. Okay, so hydrogen fluoride. So draw the two products that are formed when hex 1ene reacts with HF. Now, you might want to draw hex 1ene out, okay? And then there's two products we can get if hex 1ene reacts with that. Okay, so I'll leave that there. Give that a go. Make sure you send your work to me through my email, and that is us. So thanks.